Okay, hello everyone. In a new video, in this one we are going to explain part 1 of chapter 11, which is the chapter of pressure in liquids in the third unit of mechanics. Then let's start by section number 1, which is given by the atmospheric pressure. And Pascal's theorem. Then in this section we are going to introduce the notion of the atmospheric pressure and make some important statements. Moreover, we are going to introduce state Pascal's theorem. Then let's start. Now, if you consider Earth at a very large scale, this is the image of the Earth. So at a very large scale, we know that any object any object classified as a solid having a mass is being acted by the force of gravity, which is the weight of the object. So the weight is the force exerted by Earth on any object. Actually, this force prevents any object from falling apart from Earth. So suppose here we have a solid as having a mass. This object will not fall down due to the force of gravity exerted by Earth on the solid S. But this force not only acts on solids, but on all states of matter that are given by solid, liquid, and gas as well. Why? Since all of these states are states of matter and they have mass, then they will be directly subjected to the force of gravity. Since we are interested in the atmospheric pressure, then we will consider only the state of matter which is given by gas. Knowing that Earth is surrounded by a layer of air called the atmosphere. So this is the atmosphere. And air is trapped here between the atmosphere and the Earth. So let's write down our Earth is surrounded by a layer of air so this is the atmosphere here. Called the atmosphere. So this is the layer of air. This layer of air, which is the atmosphere, cannot escape because it's always attracted by the force of gravity. Then let's write down the gravitational force constantly pulls this air towards itself. So what I mean here, so this is the Earth that's found in this region around the Earth. And this layer is known to be the atmosphere. Because the air, which is classified as the gas, which is a state of matter having a mass, this air cannot escape because it's always attracted by the force of gravity due to Earth. And now, as Earth is pulling the air that's found around it toward itself, then the Earth is pulling the atmosphere toward itself. This action causes the atmospheric pressure. Then we can say, due to this the atmosphere exerts a pressure on Earth. This is known as the atmospheric pressure. Then what we have explained so far is the atmosphere and what causes the atmospheric pressure. Then let's do a small recap. Then around the Earth there is a layer of air surrounding it called the atmosphere. So this atmosphere cannot escape because of the gravity. As the gravity pulls this atmosphere, which is the layer of air, then Earth is pulling this atmosphere toward itself. This action, which is the pulling of the atmosphere toward the Earth, causes the pressure, and this pressure is known as the atmospheric pressure. And now let's consider this horizontal surface of Earth. So then air is found here. This is the atmosphere, which is the air. So let me write here between the brackets, this is the atmosphere. And the gravity is pulling this air or this atmosphere constantly downward. So because gravity is pulling this air toward the surface, this causes pressure on the surface, and this is known as the atmospheric pressure. And all objects that are found on this surface are being submitted to the atmospheric pressure. Then we can say, for example, that this object A here, so suppose we have an object A here on this surface, on the horizontal surface. So let's say that this is an object S. Then because the object S is at the surface of Earth on this horizontal surface, then it's being submitted to the atmospheric pressure. And not only this object, but all objects that are found on this surface. For example, if you consider another object here to be a cube on the surface, then this cube A, then the cube A is being submitted to the atmospheric pressure. And this is very important. Let's write it down. All points and objects on the surface of Earth are submitted to the atmospheric pressure. Full point. And here the word submitted means subjected to. Now if you consider this document, so this is a container containing liquid. Let me write in the JSON document. A container is filled with a liquid L, and A, B, C, and D are points in this liquid. Now, as I have said in the beginning of this section, we will make a list of important statements. So let's start. Okay, let me repeat that this is the container containing liquid L. This liquid may be water, alcohol, oil, etc. So all of these statements are independent of the nature of this liquid. Now A, B, C, and D are points in this liquid. The points A and B are at the free surface of this liquid, so they are at the free surface. And above the points A and B there is nothing found. So here there is gas, and the points C and so let this free surface be the level 1, and the points C and D are points inside of this liquid, not at the free surface. They are at the same level, the horizontal level 2, and this dotted line indicates that they are in the same horizontal level. So let me make statement number 1, or idea number 1. So notice that here the point A is at the free surface of this liquid, and it's open to the atmosphere. So here we have the atmosphere, because nothing is found above the point A. By nothing I mean solid or liquid. So the point A is being submitted to the atmospheric pressure simply because it's open to the atmosphere. Then let me write down the point A is submitted to the atmospheric pressure. And in this case we have that the pressure at the point A is equal to the atmospheric pressure. Notice that here I'm not calculating the atmospheric pressure, or I'm not calculating the pressure at the point A. However, I'm just making an equality between the pressure at the point A and the atmospheric pressure. Why A is submitted to the atmospheric pressure? I repeat, because simply A is open to the atmosphere, therefore it will be subjected to the atmospheric pressure, knowing that we are performing this experiment on a planet, so the force of gravity exists. Now, not only the point A is submitted to the atmospheric pressure, but also the point B, because simply it's open to the atmosphere, and all points of this surface. Now we are ready to answer the following question. So what is this question? Okay, why the free surface of any liquid is always horizontal? So the free open surface why the free surface of any liquid is horizontal? Now notice that because this free surface is open to the atmosphere, then all points of this liquid are being equally submitted to the atmospheric pressure. So all points of this liquid are equally submitted to the atmospheric pressure, and knowing that this container is at equilibrium, so the liquid is at equilibrium, it's not moving. For this reason, they are in the same horizontal level. So let me write down here. Now I will only consider the points A and B. So why they are in the same horizontal level? Because they are equally submitted to the atmospheric pressure, and they are in the same liquid at equilibrium. So let's say A and B are in the same liquid, comma. So this is important that they are in the same liquid at equilibrium. And submitted to the atmospheric pressure. So then A and B are in the same horizontal level. Then here let me repeat. The question was why A and B are in the same horizontal level. So here question mark. Then the answer would be because they are in the same liquid at equilibrium and submitted to the atmospheric pressure, which means that they are submitted to the same pressure. Now other way around, one can ask why the pressure at the point A is equal to the pressure at the point B. And here, let me make this clear. I'm not asking why the points A and B are submitted to the atmospheric pressure. So A and B are submitted to the atmospheric pressure because simply both of them are open to the atmosphere. But here, independent of what is the value of the pressures at the point A and B, the question is why the pressure at the point A is equal to the pressure at the point B. So the answer would be because A and B are in the same liquid at equilibrium, because this container is not moving, and because they are submitted to the same pressure, which means that they will be in the same horizontal level. So let me write down A and B are in the same liquid at equilibrium, and in the same horizontal level. Then A and B are submitted to the same pressure. Now don't get confused because this is very easy, and let me explain more. Suppose this document is a part of an exercise, and the question is that why A and B are in the same horizontal level So the question is that why A and B are in the same horizontal level. Such type of questions are always answered by rule of 3, and the rule of 3 is given by same liquid at equilibrium and either we say same pressure or same horizontal level. Since here the question is that why, we need a justification that why A and B are in the same horizontal level. So since we are interested in justifying why they are in the same horizontal level, we will eliminate this, and our answer will be same liquid at equilibrium and same pressure. However, if the question is given by, so I repeat that this is a part of an exercise, and now the question is given by that why A and B have the same pressure. So as I have said, that such type of questions are answered by using the rule of 3, and the rule of 3 is given by that same pressure at equilibrium, and either we say same pressure or same horizontal level. Since we are interested in justifying why the points A and B have the same pressure or submitted to the same pressure, sorry, here it is same liquid, then so I repeat, we are interested in justifying why the points A and B have the same pressure. So since we are interested in this justification, we'll eliminate it, and our answer will be same liquid at equilibrium and same horizontal level. Moreover, these two statements number 2 and 3, not only apply for any 2 points A and B on the surface of this liquid, but for all points on this surface. Then let me write down idea number 4. In idea number 4, we need to justify. So we are in idea number 4. Suppose that idea number 4 is introduced by the following question: why all points of level 1 are in the same horizontal level. So by answering this question, we will be stating idea number 4. So the question is given by that why all points of level 1 are in the same horizontal level. So such type of questions are answered using the rule of 3. The rule of 3 is given by same liquid at equilibrium. And either we say same pressure or same horizontal level. So since we are interested in justifying why all points of level 1, which is the free surface, are in the same horizontal level, then we will eliminate this. Our answer will be because they are in the same liquid at equilibrium and submitted to the same pressure, and in this case this pressure is given by the atmospheric pressure. Then let me write down idea number 4. All points of level 1. So level 1 correspond to the free surface of this liquid, and let me put this between brackets. So this is not important. I mean the brackets here are not important. Are in the same liquid. So this is the first point. At equilibrium. And for sure submitted to the atmospheric pressure, because these points of level 1 are open to the atmosphere and submitted to the atmospheric pressure. Then all points of level 1 are in the same horizontal level. And now idea number 5, the other way around. Suppose that idea number 5 is introduced according to this question. So why all points of level 1 have same pressure? And here I repeat, we are not justifying why all points of level 1 are submitted to the atmospheric pressure independent of the value of this pressure, whether it's the atmospheric pressure or pressure due to a liquid or due to a solid or etc. So we are just asking why all points of level 1 have the same pressure, and such type of questions are answered using the rule of 3. And the rule of 3 is given by either we say we say always same liquid at equilibrium, and either we say same pressure or same horizontal level. Since we are interested in justifying why that all points of level 1 have the same pressure, then we will eliminate this, and our answer will be same liquid at equilibrium and in the same horizontal level. So this is idea number 5. All points of level 1 are in the same liquid. So this is the first point, at equilibrium. And submitted, and in the same horizontal level. For this reason, then all points of level 1 are submitted to the same pressure, which is in this case the atmospheric pressure. Now let me move this document down. Wait. Okay. Let me drag it. Okay, so far the discussion regarding the pressure was related to the free surface of this liquid. Now we are interested in discussing the same statements and ideas but inside the liquid. So let's say here, okay, so A is being open to the atmosphere, so A is subjected to the atmospheric pressure. What about the pressure at the point C? So notice that here the point C is found at a horizontal level, which is given by level 2, which is lower than the horizontal level of the point A, which is given by level 1. Then we are interested in comparing the pressures at the point A. So PA represents the pressure at the point A and the pressure at the point C, which is given by PC. So what we can say is that the pressure at the point C is greater than that of the pressure at the point AY, because C is found at a horizontal level lower than that of A, and as we go down deep inside the liquid, the pressure increases. So let me write idea number 6, which is given by: as the depth in a liquid increases, then the pressure exerted by liquid increases. And this idea or this fact can be justified using Pascal's theorem, which is given by then statement number 7, Pascal's theorem. Pascal's theorem is given by that liquids transmit wholly and in all directions the variations of pressure to which they are submitted. And here the word transmit means sends out or sends to. Now referring back also to this document, so as we said that A is being submitted to the atmospheric pressure, and according to Pascal's theorem that liquid transmit the pressure. So here the point C, between the point A and C we have this layer of liquid. Because A is being submitted to the atmospheric pressure, and according to Pascal's theorem that the liquid transmit pressure, so therefore the point C will be also subjected or submitted to the atmospheric pressure Why C will be submitted to the atmospheric pressure? Because between the points A and C we have a liquid, and according to Pascal's theorem, liquid transmit the pressure. So it can send out the value of the pressure from the point A to the point C. But not only this, notice that also C will be submitted to another pressure, which is the pressure due to this liquid, and to the pressure of the liquid. Which liquid? Actually, the layer of liquid which is found above the point C. So whenever we are interested in determining the pressure, we always look upward. So looking upward above the point C, we have this layer of liquid and we have the atmosphere. Therefore, the point C will be subjected to the atmospheric pressure and to the pressure of the liquid. So let me here write also statement number 8, which is given by C is submitted to the pressure of the liquid and to the atmospheric pressure. Then the pressure at the point C will be given by to the pressure due to the liquid. So we'll denote this pressure to be PL. L stands for the liquid, plus or and to the pressure of the atmosphere. So this is an equality between the pressure at the point C and to the pressure of the liquid plus pressure to the atmospheric pressure. Recall that this pressure of the liquid is only due to the pressure exerted by this layer of liquid, which is found above the point C. So here the point C, let me repeat, it's being subjected to two pressures, to the atmospheric pressure and to the pressure due to the liquid. So this PC stands for the total pressure. Let me write it here. This is the total pressure at the point C. Now, using Pascal's theorem, we can justify statement number 6, why as the depth in a liquid increases, then the pressure exerted by liquid increases. So because C is submitted to two pressures, which is the atmospheric pressure plus the pressure due to this liquid, due to the layer of this liquid, and regarding the point A is only submitted to the atmospheric pressure. For this reason, the pressure at the point C is greater than the pressure at the point A. For this reason, as the depth in liquid increases, then the pressure exerted by liquid increases. So now after we have stated Pascal's theorem, we are ready to repeat these statements, but now for the level 2 and not the level 1. So now we can explain why both points C and D are located in the same horizontal level. So notice that here, because the point C is being submitted to the atmospheric pressure and to the pressure due to the layer of this liquid. Now as for the point D, it's being also submitted to the atmospheric pressure and to the pressure due to this liquid, which means that they have the same pressure and they are in the same liquid at equilibrium, so they are located in the same horizontal level. So idea number 9, we need to justify why the points C and D are located in the same horizontal level. So why C and D are in the same horizontal level. And as we have said previously, that such type of questions are answered using the rule of 3, which is given by same liquid, at equilibrium. And finally, either we say same pressure or same horizontal level. Since we are interested in justifying why the points C and D are in the same horizontal level, we will eliminate this, and our answer will be same liquid at equilibrium and same pressure. Then idea number 9 is given by that C and D are in the same liquid, comma, at equilibrium, and submitted to the same pressure. Then C and D are in the same horizontal level. Now suppose that we are interested in justifying why the points C and D are submitted to the same pressure. And such type of questions are answered using rule of 3. So now we are introducing idea number 9, idea number 10, which is given by the following question. And the rule of 3 says that it's given by same pressure, same liquid, and finally either we say, so sorry, here it's the rule of 3 is given by same liquid at equilibrium, and either we say same pressure or same horizontal level. Since idea number 10 is introduced by the following question, that C and D are in same pressure, have same pressure, question mark. Since we are interested in justifying why they have same pressure, we will eliminate this, and our answer will be same liquid at equilibrium, and they are in the same horizontal level. So C and D are in the same liquid at equilibrium, and in the same horizontal level. Then C and D are submitted to the same pressure, and in this case we can write down the equality between the pressures at the point C and the point D, which is given by that the pressure at the point C is equal to the pressure at the point D. And not only this, but these two statements of numbers 9 and 10 apply not only to the points C and D, but to the all points of level 2. Then let me write down idea number 11. All points between the brackets of level 2 are in the same liquid at equilibrium and submitted to the same pressure. Then all points of level 2 are in the same horizontal level. And vice versa for idea number 12. Now we can say that all points of level 2 are in the same liquid at equilibrium and submitted, and in the same horizontal level. Then all points of level 2 are submitted to the same pressure. We still have one more statement to write down, but before doing so, let me explain the following. Suppose here we have a support, which is a table, say for example. So this is a table, and above this table we have a solid S that is resting on the table like this. So this is a table or a support, and this is a solid S. So this is a state of matter. It's not a liquid nor a gas, it's a solid. So this is a solid, and let's consider 2 points above each other. So this is the point A and this is the point B. So notice that here we are discussing pressures and not forces. Later on we'll see the relation between the pressure and the force. So we can ask the following question: what's the pressure at the point A? So whenever we are interested in the pressure, we look upward. So notice that A is being open to the atmosphere, then A will be subjected to the atmospheric pressure. Now what about the point B? Okay, B will be submitted to the pressure of the solid. This pressure is known as the okay, later we'll discuss this pressure, but however what I wanted to say that B will be not subjected to the atmospheric, because according to Pascal's theorem only liquids transmit pressure, only liquids. So solid cannot transmit the atmospheric pressure from the point A to the point B. However, B will be only subjected to the pressure due to the solid S. Later on we will see how to calculate this pressure, and indeed it's related to the forces, to the normal force or to the weight. And now finally, idea number 13, which is related to the vacuum. So vacuum is a part of space in which it is free from everything So suppose here we have a box, and inside this box we have a vacuum. So by vacuum here, that this is space inside the vacuum, it's free from everything, and in particular the three states of matter. So this vacuum is free from solids, solid, liquid, and gas. So it's free from everything. Now we can ask the following question: if you consider here any point to be the point E, so what's the pressure at the point E, knowing that it is found inside a vacuum, and by vacuum it's free from everything, and in particular the three states of matter. So here let me write including air, because air is a state of matter which is gas. Okay, so let me say also that let E be a point in the vacuum. So E is submitted to the pressure of the vacuum, which is 0, because nothing is found in the vacuum in order to exert a pressure. For this reason, the pressure in the vacuum is 0. Then we can say that the value of the pressure at the point E is equal to 0. So notice that here I didn't include any unit for 0, because 0 multiplied by anything is 0. It doesn't mean that the pressure it does not have a unit. Actually, later in the coming sections we will see what's the unit of the pressure. And now let's solve the following exercise as a direct application on what we have explained. So consider a container filled with a liquid L. So they are talking about this document. A and B are at the free surface of the liquid and submitted to the atmospheric pressure. Okay, so notice that A and B are at the free surface of the liquid. Above the points, so whenever we are discussing pressure, we always look upward. So looking upward, A and B are open to the atmosphere, therefore they are submitted to the atmospheric pressure. C and D are points inside the liquid, so C and D are found at the horizontal level too. So number 1, they are telling us A and B are in the same horizontal level, justify. So always such type of questions are justified using the rule of 3, which is given by same liquid at equilibrium, and either we say same pressure or same horizontal level. Since we are interested in justifying why the points A and B are in the same horizontal level, we will eliminate this. Then our answer will be because they are in the same liquid at equilibrium and submitted to the same pressure, and in this case the same pressure is given by the atmospheric pressure. Notice that here they didn't mention anything about the equilibrium, but for sure we take it to be in equilibrium. Okay, so let's say since A and B are in the same liquid, at equilibrium, and submitted to the same pressure. In this case, the same pressure is given by the atmospheric pressure. and submit it to the atmospheric pressure. For this reason, then A and B are in the same horizontal level. Now, idea number 2, question number 2, all points at the level 1 are under the same pressure, justify. So they are telling me that they are under the same pressure, which is the atmospheric pressure, but they need a justification. And such type of questions are always answered using the rule of 3. So the rule of 3 is given by same liquid at equilibrium. Either we say same pressure or same horizontal level. Since we are interested in justifying why they have the same pressure, so we will say that all points of level 1 are in the same liquid at equilibrium and in the same horizontal level. Then all points of level 1 are submitted to the same pressure, which is the atmospheric pressure. Now, question number 3. The pressure at A is transmitted to the point C according to a certain theorem. State this theorem. So for sure they are talking about Pascal's theorem. So the point C, in addition to the pressure due to this layer of this liquid, will be submitted to another pressure, which is the atmospheric pressure due to Pascal's theorem. Because we know that according to Pascal's theorem, liquids transmit wholly and in all directions the variations of pressure to which they are submitted. And now question number 4. The pressure PC is greater than the pressure PA, justify. So they are telling us that the pressure at the point C is greater than the pressure at the point A, but we need justification. So notice that the point C is found at a horizontal level lower than that of A, and knowing that as the depth in a liquid increases, then the pressure exerted by liquid increases. Then we have that the pressure at the point C is greater than the pressure at the point A. Now question number 5. C and D are submitted to the same pressure, justify. So always such type of questions are answered using the rule of 3. For sure we will say that since C and D are in the same liquid, at equilibrium, then we will either say same pressure or same horizontal level. But since we are interested in justifying why they have the same pressure, then we will eliminate this, and our answer that completes this will be the same horizontal level and in the same horizontal level. Then C and D are submitted to the same pressure. Now finally in number 6 they are telling us all points at the level 2 are in the same horizontal level, justify. So this type of questions is always answered using the rule of 3, which is given by since all points of level 2 are in the same liquid, at equilibrium, and here we will either say same horizontal level or same pressure. Since we are interested in justifying why they are in the same horizontal level, then we will eliminate this, and our answer that completes this will be and submitted to the same pressure. Then all points of level 2 are in the same horizontal level. And by this we have finished solving this exercise. So that's it for me in this video, guys. In the next part we'll complete the explanation of this chapter.